Welcome to our webinar. My name is Carlos and I will be your host for the next hour, and I'll try my best to give you a general idea of two of our open BIM solutions, named TreeCalc for structural analysis and Jest plus MidPlan for creating detailed project budget from BIM EFC files. I hope you'll enjoy our presentation, and at the end there will be a question session where you can participate. First of all, I will start by presenting the content of our webinar in a very simple way. We'll be presenting two open BIM solutions, so our presentation will be divided in two major parts. Part 1, structural design with TreeCalc, and Part 2, detailed budget with Jest plus MidPlan. Part 1 of our webinar will be focused on the relation between the BIM model, even with a low level of detail, and the structural model in TreeCalc. TreeCalc can import the structural elements from the BIM model, the ones that are classified as structural elements or undefined elements, such as EFC beams, EFC columns, EFC slab, EFC roof, and convert them in a structural model in TreeCalc with the help of some automatic functions that correct the most typical errors when passing from the architectural model to the structural model. For example, where should the end of the column be, at the base of the beam or at the top of the beam? That is a problem that we have when we are passing the BIM model to structural models, and the TreeCalc can correct that error automatically. After the conversion is done, TreeCalc will do the structural analysis of the model, including wind and seismic analysis. TreeCalc has yet the capacity of detail all the rebar reinforcements of the structures in 2D, 2 dimensions draws or project sheets, and 3D foundations and columns rebar reinforcements models, as illustrated in this image and in our presentation ahead. Also, steel beam and columns connection are detailed in 2D and 3D. All the information of the 3D model from TreeCalc will be exported back to the BIM model via EFC file, including rebar reinforcements, connections, piles, beam, columns, slabs, and all the other elements that TreeCalc has the capability to model. The second part of our webinar will be focused in the connection between the BIM model and the detailed budget of the project. In only 3 steps, Jest plus MidPlan can, beginning with the simple code defined in the BIM model, make a quantity extraction to justify detailed cost estimates. The detailed project budget is achieved with one link defined by MidPlan that make the connection between the quantities and the resources needed to do that element. Okay. Let's start exploring how structural design based on one BIM model is done with TreeCalc. First of all, let's start by looking at what is TreeCalc. TreeCalc is a structural analysis program that models and analyzes in 3D. Plus, TreeCalc does all the detailing of the elements reinforcements in 2-dimensional draws or sheets, and models the foundations and columns reinforcements in 3D, 3-dimensional model of the structure. So let's open TreeCalc and see several examples of structures modeled and calculated with TreeCalc. The first model is a concrete building with some steel bars and wood bars. It also has suspended stairs, shear walls, and some cantilever slabs, all integrated in one model. As we can see, TreeCalc models and represents in 3D all the connections between the steel bars, including the connections between the steel bars and the concrete elements, and also the reinforcements in the structure. I will call one level and apply the reinforcements visibility in the structure. And here are the reinforcements modeled in TreeCalc that will be exported to the BIM model later. If we want, we can activate another level, for example this one, and see how the columns reinforcements are overlapped in this 3D model. As you can see, it's a very good representation in 3D. And all this information will be exported back to the BIM model, as we're going to see later. But let's take a closer look to the versatility of TreeCalc. So I will now turn off the visibility of the reinforcements and analyze level by level this structure. Beginning with the foundation, we have here several types of foundations. We have piles, pile caps, footings, walls. Also we have some shear walls in here with a foundation slab, and all this can be integrated in one model. In the next level we have a slab with beams modeled in TreeCalc and shear walls with its openings in here. In the next level we have a solid slab that is supported directly by columns. We also have some cantilever slabs, and we can go on seeing our structure, including the steel bars and the wood bars, integrated with the concrete structure. As said before, there's always the possibility of modeling the connections between the steel elements and the steel and concrete elements. We also have here a suspended stair model with TreeCalc. So as you can see, this is a very multifaceted structure made with TreeCalc. But let's see another one. So let's open another structure. This one is also a concrete structure, a very big structure with temperature analysis, and I will show you the capacity that TreeCalc has to define structures with or based in 2D draws, 2D AutoCAD draws. Here is the draw that came from AutoCAD and the structure that was implemented in TreeCalc using snap functions and CAD functions. Okay. We can use this type of information even when we are analyzing displacements, forces in the 3D model of TreeCalc. But let's back to the structure that we have seen before. And let me show you some of the capacities of TreeCalc in analysis. TreeCalc make a multi-degree of freedom system with 6 degrees of freedom by nodes in one linear elastic stiffness matrix. All the elements are integrated in one stiffness matrix. So the interaction between the different types of elements is always considered by the program. And after the analysis is done, we can do some checkings on the structure behavior, like see, for example, the displacements of one level of the structure. For example, we can go to this level and search for a graphical displacement that can be in a limit state or in serviceability limit, in this case for the concrete elements, and we'll have here the displacements of this level and here the amplitude of those displacements. We can also call another type of graphic representation, the ISO values, and in here call for the envelope displacements of this level. Okay, and as you can see, the biggest displacements are in this area. These graphics are permanent represented, and we can make zooms on the structure, displace the structure, rotate the structure, and they always be represented. We can even call several planes, for example a vertical one, and have them represented at the same time in our screen. There are other types of graphical information that we can rapidly check on TreeCalc, like for example a bending moment graphic in here. Is a representation for the envelope graphic, but we can define, for example, for the dead loads, the representation of the bending moments. This representation can have the values displayed in the graphical. We can also check how the program shows us the axial forces on this plane. Plus, TreeCalc can give us the possibility of study the reinforcements that were designed, that were defined by the program based on our predefinitions. So we can always go to reinforcement, select one draw of the reinforcement. Here are the column reinforcements, the beam reinforcements. There are several options that we can activate or deactivate. For example, if we don't want to see the stirrups, we can deactivate this option and they will not be seen in here. They only will be represented in here. We can also, for example, tell the program to not draw the column cross sections in this row. Okay. There are also another types of representation like this one that puts the upper reinforcements in here and the lower reinforcements in here. Let's activate the draw of the columns and show you how you can get all the information from the program. For example, by clicking on this column, we have here the reinforcements that are on this column, and we can check all the cases that were analyzed by the program. Okay, the combination for the maximum compression, maximum tension, maximum bending moment in Z, in Y, and the worst case. And the performance factor of the column will be 89%. Then we have here more detailed information like the compression relation between acting and resistant, the bending moment in one direction and the bending moment in another direction. So we are talking about composing axial and moments analysis. Also, the program shows information about some code definitions like the geometric quantity of rebars, about slenderness, limit slenderness, buckling length factor, elastic eccentricity, accidental eccentricity, first order, second order, yield eccentricity, and also the shear analysis of the reinforcements. The torsional moment also, and all the information is here for you to have security in what the program has done. Okay, this is a little presentation of the capacities of TreeCalc. You can also draw all the reinforcements for slabs, shear walls, but this is only a little preview. You can check more information on our YouTube channel. If you go to YouTube and search for Arktec Portugal, you will see our channel and our videos that explain a lot better what TreeCalc is, because TreeCalc is our today big program with big capacities. Just finishing this TreeCalc preview, saying that TreeCalc do a seismic analysis that can include a dynamic analysis based on seismic response spectra. Okay, and these seismic loads can be defined with any spectra that you can input in TreeCalc. So let's back to our connection between the architectural model and the structural model, the BIM model, and TreeCalc. And the next point is how TreeCalc imports BIM models. It's quite simple, in fact, and TreeCalc has some features that can adapt the architectural model to the needs of a structural program. TreeCalc can import all the elements defined in the BIM model as structural or undefined, and those elements are EFC walls, EFC wall standard case, EFC slab, EFC room, beam, columns, etc. TreeCalc has an import filter where the engineer can define additional parameters for the import functions. If you want to import all the elements or put some filters to that import process. After importing the BIM model, TreeCalc can adjust the model with several automatic functions that gives the engineer enormous productivity. For example, extend the length of the columns to achieve the top of the slab or the top of the beam. That is automatically done by TreeCalc, and if the engineer will do that work, it will take a long time to do that in all the columns of the structure. Finally, TreeCalc converts the beam model in a structural model where all the analysis is done by TreeCalc. So let's see this process in action. Back to TreeCalc, we'll go to open a new structure. We call it EFC import, for example. And on the file menu, we got the import function, beam model open, and we only have to select EFC file. We can import the EFC model complete with all the furnitures, people, etc. But for our purpose, we only need the structural elements. So we can start our structural analysis or in early process, because we only need a low level of detail to import our structure elements to TreeCalc. So I will choose a file, a EFC file that only contains the structural elements that I need for my study. I click on the open button, and here are the first filter that TreeCalc has. This filter includes some entities, and we can check which entities we want to import to our program. In this case, I will import all the EFC elements that TreeCalc can import, like EFC wall standard case, EFC wall, slab, roof, column, beams, members, and building element proxy. But then we have here another filter that we can use for the importation. For example, if there are walls defined as bearing walls, as structural walls in the beam model, but are less than 15 centimeters of thickness, I don't want to import them to TreeCalc. So I put this filter on, and I accept these conversion filters. A resume of the importation, okay. A security copy for the structure that for the model that is imported. I will say no at this time. And if we have activated the representation of the beam model in TreeCalc, we will see the beam model that came from, in this case, the Archicad program. Okay, we can see it as a wire, or we can see as a solid elements. And here are some problems that are typical with the structures and architectural models. This column doesn't achieve the top of the slab or the top of the beam, so the engineer will have to extend this column to the top of the slab or the top of the beam in every level and in every column. This is a time consumption work that is not productivity. So we can use in TreeCalc some automatic adjustments that solve most of the typical errors when taking an architectural model on a structural program. For example, place the extremes of columns on the upper face of the slab. And if we apply these adjustments to our model, we can see that all these were corrected, and a lot of minutes or perhaps hours were taken from our project. Okay, so productivity is the word in here. So this is the BIM model in TreeCalc, but it's not yet a TreeCalc model. We have to convert this to a TreeCalc model. And we have the creation settings that can be general or can be assigned to an element, a specified element, that we can use to convert the BIM model to a TreeCalc model. So what we are saying in this box is, I want to create the BIM that came from the BIM model in a BIM of TreeCalc model and keep the cross section that came from the BIM model. I want to import the columns from the BIM model to TreeCalc and keep the cross sections, or define my own sections if I want. The slabs that come from the BIM model will be a solid slabs, and I can define the thickness of that slab and also the loads of that, the surface loads of that slab. And for the shear walls, what type of shear wall I want is a wall that is a concrete wall with these reinforcements, and I can define here some parameters of that wall. But all the walls will be converted to concrete walls. And so these are the general creation settings, but we have here a foundation slab, so we will assign a different type of slab to that element. Foundation slab with a depth of 80 centimeters and the loads that I want to apply to that slab, and assign these creation settings to this element, clicking on him or opening a selection window. So we are now ready to do our conversion using the function create TreeCalc model. And we can see now that we have here a lot of information that we haven't before. And if we turn off the visualization of the BIM model that came to TreeCalc, we'll see the TreeCalc model in here with our foundation slab, with our solid slabs in the other levels, with our shear walls, columns, beams. Everything was imported and converted to TreeCalc. So in TreeCalc we will do our analysis. As seen before, TreeCalc has several capacities of analysis, and then export back to the BIM program, in this case to Archicad, the structure with our new cross sections, with our new elements, and with our reinforcements in columns and footings, for example. As we don't have enough time, I will close this structure and open a similar one that is being calculated before. So I will go to my gallery projects and call for the structure that is calculated already. and then we'll see what information TreeCalc exports to EFC. Okay, then back in TreeCalc, we can select the levels that we want to export, all the structure, or for example just two levels of the structure. For example, these two levels. And the exportation method is working as a what you say is what you export function. So I will activate the reinforcements. Okay. The program will show you now the reinforcements in all these columns. Okay. Let's take a closer look. Here are the reinforcements on square columns or in circular columns. Okay. And I will export only these two floors, two levels, using the function create BIM model. And I will put on my desktop with this name. And they are exported back to EFC files to our BIM model. So let's see in Solibri, for example. I will go close this model and open the model we just create. Here it is, open in Solibri. We can also open it in Arktec, but let's see first in Solibri. And here is our structural elements that came from TreeCalc. Okay. So if we want, we can hide the section, the concrete section, and see the reinforcements in Solibri. Okay. As you can see, we have taken in consideration the recommendations from the Euro code and changed this tie-up ends level by level. Okay. We can also, for example, hide this concrete section, and here are the rebars. Okay. But let's see another type of representation in Solibri, another model of TreeCalc. I will close this one and open this one. I'll let you show you other types of information that TreeCalc can export. This is the first structure we have seen in TreeCalc. It also has here the reinforcements, the rebar reinforcements, but we also have in here information of the connections made in TreeCalc. Okay. The plates and all the bolts are presented in here. And the plate also represented in 3D model. Okay. And let's see in Archicad the building that was exported to TreeCalc. Okay. We can see that is a very complete building with furnitures, peoples, the structure. Okay. You can also see this in a 3D view for the 5th level, for example. Okay. Here are the beams, the columns. Okay. And if we want, we can now merge the BIM model that is done by TreeCalc in this BIM model in Archicad. Okay. This was the process, and Archicad will import the information from TreeCalc, only the 2 levels that we have selected, and we'll put them on a different layer for security, and then we can check all the alterations that were done in the structural program and validate them one by one. So here are the imported elements from the EFC file that came from TreeCalc in different layers. Okay. The columns in here, for example, and the beams in here. And that's it. The connection between the structural program and the architectural program is, in these days, and with TreeCalc, very easy to do. And as you can see, it can start in an early stage of the process with a low level of detail. Import that level low of detail BIM model to TreeCalc. Define our structures, our reinforcements, and exporting them back to the BIM model in Archicad, Solibri, within these 2 programs, but also to Revit or other programs. I hope you have seen this as easy as it is, and you can contact us to see a more detailed demonstration of this process if you want. So from TreeCalc, it's all shown. Let's go to the part 2 of our webinar. Well, in this second part of our webinar, we'll be focused in the area of the project budgeting in the perspective of the constructor or the owner of the project. Arktec detected some time ago the need for a program that could make the bridge between the quantities taken from the BIM models and the detailed budget project that we need to know the resources needed to our construction and also the costs of that resources. So we develop a solution that is called Jest plus Midplane that can pick any room or element on the EFC model and deploy from that element, from the meditions of that element, can deploy several items in the project budget including items in the different chapters of that budget. So let's see how this works in more detailed manner. We define this solution as a only 3 steps solution. The 3 steps are the definition of code in the BIM EFC model, the creation of links that connect the resources from JS database to a code in mid-plan, and of course the resources database done in JS. So the 3 steps are: define a code on our BIM model. The code is read by the software mid-plan. That code is programmed to collect from the BIM model some meditions and associate them to several items of our budget, including in different chapters, and with the database resources we start then to create, ingest our detailed budget. So 3 steps, it's very productivity. So let's first take a look at mid-plan and how it does the connection between the room of the BIM model, the rooms of the BIM models and the elements of the BIM models and the resources database ingest. The link between the BIM model and JS mid-plan is, for start, level of detail independent. We can link as much activities and resources we want from the JS database to a simple BIM room element or to a simplified element. For example, a simple EFC wall can deploy its structural parts, its structural resources, but also several other items in the detailed project budget, like the wall isolating and coating, electricity installation, points of light, plumbing installation, etc. at the same moment. In resume, we can start our detailed budgeting in an early level of detail model, saving time and increasing productivity. This same process can be applied to the elements defined in the BIM model, as we'll see in the next level. In here we have the image that represents the room, and the room with the code associated, the mid-plan code, will deploy several items on our budget project, and these items have resources associated in JS database. So we start to do our detailed budget from simple room elements or BIM elements in an early stage. In here we have the same process but applied to one BIM element, in this case a wall element, that is connected by a code to mid-plan, and mid-plan deploys several items of the budget associated with resources in a database, in the JS database. As we can see, each item looks for some specific meditions. So this process is programmed in mid-plan. Here is a little schematic that shows exactly what I was saying before. We have here the JS database with our materials, activities, workers. We have the classes from mid-plan and the classes from mid-plan that are deployed by the BIM elements or the BIM rooms associated with the resources, can make our detailed budget, can give us the planning, the resources, the control of the all the construction in the program JS and JSCon. So this is a schematic that shows what we said before. But let's see how this all works in the programs. For the purpose, I will go to Solibri and open a sample EFC file that we have done in Revit, I think. And here is the model. Okay. And if we choose some elements like this column in here, we can see that there is an identity data field that has a description, and this is the code that is needed by the mid-plan program. So when we are making our BIM model, for each type of element we say or we introduce the respective code of the mid-plan class. In this case, EP1 is the code that is assigned to mid-plan. And so in mid-plan, we'll go to the EFCM edition and open the class elements and look for the EP1 code. Here is the EP1 code, pilar de aço laminado or steel column. This class will deploy an article in our budget, the 5.4 article, that has this description that take the volume from our BIM model multiplied by set 7.850 and associates the resources from this GES database. So when I say to mid-plan to read the quantities from the BIM model, you will read the volume from all the BIM elements that are classified as the EP1 code and associate them to item on the budget that has this resource assigned to them. So when you go to the GES program, we'll open our database, our resource database called Enterprise Base in here, and we can look, for example, for our EEAV.0002 resource. Okay, and as we can see, the building of these steel columns is done with the help of some workers, some materials, okay, and even some equipment. For example, we can open here the crane that is needed to put the steel in place and see that there are several items in here. Okay, manutention contract, the renting of the command, the telecommand, and several other resources assigned to this steel column. This is the resource that we've seen here in mid-plan. And there are several types of information that you can introduce in mid-plan. For example, for a room that is classified I don't know, we'll choose this one that is a bathroom. We have several types of bathrooms in here, and if we define in the BIM model a bathroom room, we can assign, for example, this code, and this code will deploy a lot of articles in our budget. Okay, the coating of the floor, the coating of the walls, the painting, the points of light, all that can be, all that are items that are going to be on our budget, and the additions that are needed for each of these items, and the resources for each one of these items. Okay, so from one BIM element like the column, we can have one item on our budget that has several resources, or for example, one room defined on our BIM model, we have several items that have several resources assigned to them on our budget, on our detailed budget. And as I said before, Gest mais Midplan, Gest plus Midplan, does the connection between the BIM model and the detailed project budget, is the bridge that was needed for increase the productivity of the enterprises that work on budget projecting and controlling and planning the constructions. How this works: we open the EFC file, for example this file, the sample EFC file that is open in Solibri. We click here and the program will do the addition of all the elements in the BIM file. Here it is. Okay, and for example, the bedroom with this code in Midplan with these additions will deploy the detailed budget of these elements. And as we go here, we can see that there is a lot of elements that have not classes defined. For example, the furniture is one typical case of things that we don't want to include on our budget, so it's common that they don't have any code defined on the BIM element. These are the BIM steel beams of our model and the corresponding code and the additions. Okay, and all these additions are then exported to our Gest program. Okay, we're going to call it a sample file. We're going to put them in our desktop. Okay, some of the elements don't have codes defined. Okay, the furniture, as I said before, for example, the table dining has no code associated. And now in Gest we can close this database and open in desktop the file that came from Midplan and look at the detailed budget. Okay, here are item by item our detailed budget. But let's see in more detail. We'll open a new window and we can navigate on our budget, see all the partial additions, and see all the resources, and including the extend text of the description assigned to each of our article in our budget. Okay, the columns of steel, the steel beams. Okay, the resources needed to do this item, and so on, so on, so on. all our detailed budget here in Jest. Okay. From now on, we can do security, planning, cost controlling, contability, and a lot more in the Constructo solution from Arktec. I hope that I can explain all the 3 steps in an easy way and in a very explicit way, so we understand that in the BIM or EFC model we only have to define a code for each element type or for each room type. In mid-plan we have to define that code and the items that we will deploy in our budget and associate them to the database resources in Jest. So thanks for your attention. Don't forget to see our YouTube channel in this link, and I would like to finish sending a special thank you to Engineer António Marelos for this opportunity to present our tools for the BIM, in this case the structural tool and the budgeting tool for the BIM model. So see you soon. Thank you for your attention.